Why is dealing with complexity one of the big benefits of computing? Well, let's take an example. Imagine you have a roster of 500 students in your school. Your goal is to find David Joyner on that roster. How long does it take? Let's measure the time in terms of number of comparisons. You're comparing each name to David Joyner to see if it matches. How many comparisons does it take? If the roster is sorted alphabetically, then it likely doesn't take very long. You start near the middle, check if the first name you see is before or after David Joyner, and then you start to look in the right direction. If it's perfectly sorted, it takes fewer than 10 comparisons if you use the most efficient algorithm. If it's not sorted though, it might require up to 500 comparisons. Usually when discussing complexity, we talk in terms of worst-case scenarios, also known as upper bounds on how long something could take. 10 versus 500 is obviously a huge difference. Imagine, however, that instead of finding David Joyner, we're trying to check the roster as a whole for duplicates. If they're sorted, things become easier. Duplicates would be side by side. Our best case and worst case scenarios are the same, 500 comparisons, because we keep going until we've checked every individual item for duplicates. However, what if the roster isn't sorted? If the roster isn't sorted, then we start with the first name and compare it to the next 499 names. Then we start with the next name and compare it to the next 498 names. If we do the math, we get almost 125,000 calculations, a nearly impossible number for a person to do. Even if they were able to do 2 calculations a second, it would still take over 17 hours. The reason complexity is so important is that with inefficient algorithms, expanding dataset sizes can have massive impacts on execution time. It would take 125,000 operations to perform those comparisons on a roster of 500, but what if the roster grew to just 600? That number balloons to 180,000 operations. With 1,000 students, it would reach 500,000 operations. Doubling the number of students quadruples the number of operations required.